Hello. So I need to learn some Python, and I'm going to be taking this course on Udemy titled "The Complete Python Bootcamp from Zero to Hero in Python." And I'm going to do it live. I'm going to stream it instead of what I usually do, which is try to work on these offline. And usually I get really distracted. So when I stream something, it helps me focus on whatever I'm doing. Um, yeah, so that said, I'm going to pray for myself. Eternal God, you are the master coder of the universe, writing galaxies with precision and breathing purpose into every line of life. Your Holy Spirit empowers us beyond our limits, turning weakness into strength and fear into faith. I praise you for your infinite wisdom that guides every step of growth. Lord, I confess I've been waiting for the perfect moment to start relearning Python. I've been paralyzed by fear that I'm not capable of becoming the coder I want to be. I feel the doubt in my body tight chest, and I've let it put me through procrastination loops. Forgive me for doubting your calling and for not trusting in the strength that you give. Thank you, Father, for carrying me through 8 days of resisting November's brooding temptations with your strength. I'm grateful for the existence of AI tools to support my new coding journey and for the chance to stream tonight as I relearn Python from scratch. Thank you for your vision of solving leak code problems one day. Holy Spirit, fill me with courage and focus as I learn to code tonight. Help me embrace the discomfort of learning and trust that you're building something in me. Also, please heal Veronica quickly from her cough and whatever she's fighting. Wrap her in your comfort and give her a speedy recovery. Let the stream be a space for growth, honesty, and encouragement for anyone watching. In Jesus' name, amen.
Welcome back, everyone, to this section on Python object and data structure basics.
Oh,
So in
there's
this section, of course,
DRM,
we're going to
so
start
I
off by
guess
discussing basic data types. And
that
these are your
sucks.
basic building blocks of code when constructing larger pieces of code. And we're going to quickly discuss all the possible data types that we're going to talk about in this section, and then we'll have lectures that go into a lot more detail about each one. So don't worry about memorizing all the information shown here. This is more just a quick overview, and there's going to be a lecture on each of these data types as we go on throughout this section. So the data types that we're going to be discussing are the following in this table. Here we have the name of the data type on that left-hand column, and then there's the type. So what that means is just Python has an internal keyword for this name, and you're not going to get the whole word integer, the whole word floating point. Instead, Python has kind of a shortened keyword. So that's the second column, such as int for integer, str for strings, etc. Then we have the description column, and that's just going to be what the actual description of the data type is. So let's quickly go through these. We start off with integers, and those are just basic whole numbers, such as 3, 300, 200. Then we have floating point numbers, and those are numbers of a decimal point, 2.3, 4.6, 100.0. And notice here that even if you have 100.0, that still counts as a floating point number. That's no longer an integer because it has a decimal point. Then after that, we have strings, and strings are an ordered sequence of characters. You can think of these as just kind of words, but you should also note they can be numbers as well as foreign characters inside of a string. The main thing that denotes a string is that it either has double quotes or single quotes. Here we can see we have hello in double quotes, Sammy in single quotes. We have the digits of 2000 inside double quotes. That makes it a string. It's no longer just an integer because it has double quotes around it. And then you can also see we have some Japanese characters inside double quotes. Then we come to data structures, and data structures are a little more specialized than basic data types and data objects because they can actually hold data objects in some sort of sequence or in some sort of mapping. So here we have lists, and these are an ordered sequence of objects. Here we can see that we've been able to use square brackets and commas to have a sequence of other objects, such as the number 10, the string hello, and then the number 200.3. Dictionaries are another data structure that can store other data types, except in this case, instead of having an ordered sequence, they have unordered key value pairs. And we'll be discussing in a lot more detail how dictionaries work, but here we can see that we have a key, then a colon, and then a value, and it's denoted by curly braces as far as if it's a dictionary instead of just being a normal list, which has square brackets. But then we can have something like name, and then colon, and then the value of that name is Frankie. Again, we'll be discussing dictionaries in a lot more detail. After dictionaries, we have tuples. Sometimes they're also called tuples. and these are ordered immutable sequences of objects. They look a lot like lists, except they have parentheses, and they're immutable, meaning you cannot change an object that's already in that sequence. So we'll be discussing what immutable means in a lot more detail when discussing tuples. Then we have sets, which are an unordered collection of unique objects. And again, we'll talk about that in a lot more detail. They're a little similar to a dictionary, but they don't have key value pairs. Instead, they're just unique objects in some unordered collection. So you don't have that colon key value pair. Again, we'll discuss it in more detail later on. Then finally, we'll talk about booleans, which are just logical values indicating true or false. Notice how we have capital T and capital F. That sort of syntax is necessary for Python. So those are all the basic data types. Again, don't worry if you didn't understand any of this or didn't want to memorize any of this. We're going to have a lecture on basically each of these topics in a lot more detail and show you how you can use them to write your own code.
Oops. So I'm familiar with integers, floating point, strings, list. Not so much dictionaries, but I get how I get the syntax, but I haven't really used it in uh, when when I use Python in the past. I rarely use dictionaries, so and I don't use tuples often either. So sets I am not too familiar with as well, and booleans I know. So moving on.
Hey everyone, welcome back to this lecture on numbers in Python. We already briefly mentioned that there's two main number types that we're going to be working with throughout the course, and that is integers, which are whole numbers.
Wait, the video actually shows for this. So there's DRM on some videos and some don't have DRM. It's kind of interesting.
And floating point numbers, which are numbers of a decimal. We're going to be exploring a little bit of basic math with Python, and then we'll also discuss how to create variables and assign them values. Let's open up a Jupyter Notebook and get started. All right, so before we actually start typing any code, I wanted to briefly mention that if you ever want to toggle this toolbar or this header on or off, you can just come here, click View, and then select Toggle Header or Toggle Toolbar to turn them on or off. And typically, during the lectures, I'll have them
Crap,
off,
there's so many
so we have
options
as much
now.
space for coding as possible. Let's start off by just going over some basic math, which is pretty straightforward, and it's basically just using Python as a calculator. If you want to do addition, it's just an addition sign or a plus sign, 2 plus 1. If you want to do subtraction, that's just a dash or a minus sign, 2 minus 1. You can use an asterisk for multiplication, so 2 times 2. And if you want to perform division, that's just a forward slash, so 3 divided by 2 is 1.5. Okay, now let's take a little bit of time to discuss a mathematical operation that you may not have seen before. It's the modulo or mod operator, and basically what this does, it returns back the remainder after a division. For example, if we were to do 7 divided by 4, we get back 1.75. And if you were to do this, kind of using elementary school mathematics, you would say 7 divided by 4, 4 goes into 7 one time with a remainder of 3, because 4 plus 3 is 7. Let's imagine you actually just wanted to know that remainder, the actual number 3. In that case, you can use the mod operator, which is a percent sign. So we're going to say 7 mod 4, and it returns back 3. Because 7 divided by 4, it goes in one time evenly with a remainder of 3. So for example, we could do 50 mod 5, and if 5 goes into 50 evenly, then we get back a remainder of 0. Which is nice because it's a way to check if a number is evenly divisible by another number. That's a really convenient check when you want to check if a number is even or not. So let's imagine we have an odd number, 23, and we want to know if it's even or odd. Well, I could just look at it, but maybe sometime in my code, it's disguised as a variable, and I really need to quickly check if it's even or odd. One way I could do this is simply with a mod 2. And I know that if mod 2 results in something other than 0, then we have an odd number. Because if I have an even number, then when you divide it by 2, there should be no remainder, or the remainder should be 0. So that's the mod operator. Again, it just gives you back the remainder after you perform a division. Let's continue with everything else about arithmetic. You can also perform powers. So you can do something like 2 to the power of 3. So that's just 2 asterisk signs in a row. So 2 to the power of 3, that's 8. And then we can also perform order of operations. Let's imagine that I have the following equation. 2 plus 10 multiplied by 10 plus 3. If I run that code, I get back 105. But what if I wanted to actually have 2 plus 10 occur first, then multiply that by the result of 10 plus 3? Right now, we're following basic order of operations with math, which is going to perform this multiplication first before it does this addition. So it's performing 10 times 10, 100, plus 2, plus 3. So to have our operations happen first, the way we want them, we can use parentheses. I can say 2 plus 10 multiplied by, and in parentheses, 10 plus 3. And if I run that, I get back 156 the way I want it. Okay, so that's the basics of arithmetic and using Python as a calculator. Hopefully it was pretty straightforward. Coming up next, we're going to expand on this by showing you how you can perform variable assignments. That is to create your own variable name and then assign an object to it. We'll see you there at the next lecture.
That was pretty straightforward. Oh, welcome to a new experience. Coding exercises now appear in an IDE-like interface. You may also find instructor-provided guidance like hand solutions and related lectures. This is new to me. Okay. What do I want to do? Write an expression that equals 100. Hooray! All right, let's move on to the next one. What's the difference between a floating point and an integer? An integer has no decimals in it. A floating point can display digits past the decimal point. Why doesn't 0.1 plus 0.2 minus 0.3 equal 0.0? Well, there's 3 floats, and why is that? Minus 0.3. Whoa. 0.1. Okay, this has to do with floating point accuracy and the computer's ability to represent numbers in memory. Right. So how do I get the answer that I want? What? Uh, that doesn't work. How to fix. Is there a way to fix? Maybe you'll teach me in the next module. Uh, Wait, what was double asterisks again? I actually forget. 6. Oops. What is that? What does the operator mean in Python? Oh, exponential operator. It raises the left operand to the power of the right operand. So is it the same as this? How about the operator? Oh, that's XOR. Okay, well, cool. In Python 3, what is the output of 1 divided by 2? I mean, I think it's this, but um, it's probably going to show up as 0. No. Oh, that's why. Okay, good to know.
Welcome back, everybody. In this lecture, we're going to be discussing variable assignments. Now, we just saw how to work with numbers, but what do these numbers actually represent? We had integers and floating point numbers, but we don't actually have a variable name assigned to them. So it'd be nice if we can assign these particular data types a variable name to easily reference them later on in our code. For example, I could say a variable name my_dogs is equal to 2 because I have 2 dogs. Now, there are a couple of rules for choosing a variable name in Python, and these rules are that names cannot start with a number. There can also be no spaces in the variable name, so you should use an underscore instead. And you also can't have any of these symbols in a name. And if you accidentally forget this list of symbols, if you were to type one of these symbols out in a variable name, Python would quickly complain and you'd have an error. So you don't need to worry about memorizing all these. You'd get the error as you're typing along. A few more rules about variable names. It's generally considered best practice, according to PEP 8, that names are lowercase. Now, there are situations when you become a more advanced programmer where you're going to want to have kind of global variable names in all caps that are used throughout your code. But right now, in general, we'll want to keep all our names lowercase. And we'll also want to avoid words that have a special meaning in Python. And these are built-in keywords like list or str for string. You may be wondering, well, how the heck am I supposed to know what are the special built-in keywords? Luckily, any development environment that's designed to work with Python will have syntax highlighting that will alert you that you're using a built-in keyword by highlighting it a different color. And we'll see an example of that in just a little bit. Before we actually jump to the Jupyter Notebook though, I want to mention that Python uses dynamic typing. And this means you can reassign variables to different data types. And this makes Python very flexible in assigning data types, and that's actually different than many other programming languages that are statically typed. So let me show you an example of what I mean by this. In Python, something like this is totally okay. Here I've assigned my dog's variable name equal to 2, and then later on in my code, I went ahead and reassigned the same variable name, my dog's, to a completely different data type, a list, Sammy and Frankie. Now that's totally okay in Python, but in other languages that would produce an error, and that's because these other languages are statically typed, meaning in the other language, such as C++, you'd have to say int for integer and then say my dog is equal to whatever integer value you want, such as 1. And then later on in your code, you would not be able to assign it a different data type. You would not be able to say my dog is equal to Sammy because that's no longer an integer, and that would result in an error. So there are some pros and cons to dynamic typing in Python. The pros is that not having to write out the actual data type saves you a lot of time and makes it really easy to quickly produce Python code. And it also makes your code very readable because you're just reading that variable name. Now, this is kind of a double-edged sword here because the cons is that this may result in bugs for unexpected data type. Because you're not having these restrictions of data types, especially when you're dealing with user input, you may have unexpected data types show up, and that can cause problems later on in your operations. So you should be aware of the data types as you're coding, and you can use the special type function that's built into Python to quickly check the type of any variable. And we'll show you how to use that in just a little bit. All right, let's explore all these concepts by jumping to a Jupyter Notebook. Okay, now that we've seen how to use numbers in Python as a calculator, let's see how we can assign names and create variables. We're first going to create a very simple variable called a and set it equal to 5. And now that I've run that, anywhere in my code, when I call a, it's now assigned the variable 5. And I can reassign it simply by saying a is then equal to something else like 10. And now if I check a, it has 10 there. And I can also add now objects together. I could say a plus a, and that's going to result in 20 because 10 plus 10 is equal to 20. And Python also allows you to do reassignments with a reference to the same object. Let me show you what I mean by that. I could say a, which is still equal to 10. I could reassign it to be, say something like a is equal to a plus a. So what that is saying is take the current value of a, which is 10, and reassign it to a plus a. So that's 10 plus 10. So after I run this, a is now going to be equal to 20.
Wait, what? Didn't I just do that? Right? Did I write it wrong? Then why isn't mine 20? A equals a plus a. A. That's weird. Why didn't it work here? Anyway.
Keep in mind, if I were to run this cell a second time, so notice the in operator here, it's going to go from 40 to 42. If I run a again, it's 40 now. And you can keep doing this again and again, and you'll keep seeing it essentially.
What? Oh, okay.
Actually double each time. So keep that in mind. This is a little different than in a script environment. If you're running a .py script, you won't really see that effect because you'll just have that line once. In a cell environment, you'd have to run that cell over and over again. Okay, so let's imagine that we don't know what type is A. What you can do is use the built-in type function, so that's type, have open and close parentheses, and we'll learn how to create our own functions later on, but pass in the variable there, do Shift-Enter, and you'll get back Python's built-in keyword for what the type is. And in this case, it's int because it's an integer. Let's reassign it to be a floating point number. So we'll say 30.1. Let's check the type of that. Type of A. and it returns back that float. So these are the same keywords that we saw when we discussed that table of basic data types. Now, as we previously mentioned, you want to avoid using built-in Python keywords as variable names. And the way you could know if that's happening or not is, let's say I wanted to start assigning int equal to 4. So notice what's happening here. I have syntax highlighting on int, and I didn't get that before with a. So that means that int here is a special built-in keyword, and you shouldn't use it for something like this. So if you ever see that your variable name is having some special highlighting that a normal variable name it doesn't have, then you should avoid using this. So definitely don't ever run that. And if you accidentally ran that as you were following along, or maybe you made some other reassignment mistake, you can always come here to kernel and select restart the
Oh,
kernel, and that will restart the kernel, and it will kind of delete all the variables. So all variables will be lost. So if you ever have some weird kind of error happening because you reassigned something like list or int, you can hit restart here. It will restart the kernel, and then you'll need to run these cells again if you ever want to define anything, because if we say a here, it'll say, hey, a is not defined, so you need to rerun these cells, and then you have 5 again. Okay, so last thing I want to note is a simple example where we use variable names. So I will say my income is equal to 100. And then in this cell, I will say my tax rate is, let's say I have a 10% tax rate, so 0.1, and I want to figure out what my total taxes paid are. I will say my taxes is equal to my income times my tax rate. So I have that, and now let's check what my taxes are. How much do I owe? I'll check my taxes, and there I have 10.0. So now I can perform logic with variable names. And this is a lot more readable than just using integers or floating point numbers, because now I have this nice, almost English sentence that says my taxes is equal to my income times my tax rate. Okay, so we've learned some basic numbers in Python, we've learned how to do arithmetic, and we've wrapped it up by learning how to do variable assignment in Python. Up next, we're going to learn about strings. I'll see you there. Welcome back, everyone. In this lecture, we're going to be discussing strings. Strings are sequences of characters using the syntax of either single quotes or double quotes. Here we can see 3 examples. First, we have hello with single quotes, then hello with double quotes, and then what's nice about having both options of single quotes or double quotes, it means that if you have a single quote in your string that you want to keep and not have that end your actual string, you can wrap it in the other type of quote, such as double quotes or vice versa. So here we can see I don't do that has a single quote in there, but we don't want that single quote to suddenly end the string, so we can wrap the whole thing in double quotes. And we'll see an example of that later on in the Jupyter Notebook. Now what's important to note here is that strings are ordered sequences, and that means we can use indexing or slicing to grab
wait, what? What was? I forget
example of
what the
that later on
difference
in the
was.
Jupyter Notebook. That has a single quote in there, but we don't want that single quote to suddenly end the string, so we can wrap the whole thing in double quotes. And we'll see an
Oh,
example of that
okay.
later on in the Jupyter Notebook. Now what's important to note here is that strings are ordered sequences, and that means we can use indexing or slicing to grab subsections of the string because we know each character has a specific position to be in. And indexing notation, it uses that square bracket notation after the string or the name of the variable assigned to the string. And we're going to see lots of examples of indexing and slicing in just a little bit. So indexing is the term used when you want to grab a single character from the string. So the way this works is that every single character has an index position assigned to it. So you start at 0. That's another important note in Python, that indexing starts at 0. So H has the corresponding number of 0, E has the corresponding number of 1, L2, L3, O4. So if I wanted to grab the E, what I would use is inside the square brackets, I would pass in a 1 after the string, and then it would return back E. And we'll see examples of that later on. What's also interesting about Python is you can actually use reverse indexing. So maybe you wanted to grab the last letter of a string, but you didn't actually know how long the string was. All you knew was you wanted to grab the last letter. Well, luckily there's reverse indexing available to you, so you can go just grab -1, and it'll grab the last letter of the string regardless of how long that string actually is. Slicing allows you to grab a subsection of multiple characters, otherwise known as a slice of the string. And this has slightly different syntax. Again, it's going to be in square brackets, but because we're grabbing a subsection, we're going to be able to define three parts of this. We're going to be able to say start, stop, and step. So again, this goes in square brackets with a colon separating each of these three terms. Start is going to be the numerical index of the slice start. Stop is going to be the index you will go up to, but not include. So that's an important note there. And we're going to really focus on that in the examples we'll see in just a bit. And then step is the size of the jump you take from start to stop. Okay, so let's explore all these concepts. They're going to make a lot more sense when we actually see the code examples. Let's hop over to a notebook. Okay, let's quickly show a couple of examples of a string. Again, we can use single quotes, hello, or we can use double quotes. So here I say double quotes with world. You can also have an entire phrase, doesn't need to just be one word. So we can say this is also a string. So we have a whole phrase there, and the white spaces count as characters inside of this string. Now, something we should note here is that we can mix single quotes and double quotes. So if I'm going to say something like, for instance, I'm going on a run. So note what's happening here. Because I'm using single quotes on the outside, only part of this is getting highlighted with the syntax. So this is going to confuse Python because it thinks that you're trying to end the string here, when really I'm trying to end the string here. So if I try to run the cell, it'll say an error here, invalid syntax. What I really want to do is wrap this in double quotes, and that way I won't have an error when I have this single quote in here. So then when I run this, Python has no problem. It says, okay, I get what you're trying to do here, trying to have a single quote there stay, and that's actually not part of the definition of the string. So now let's discuss actually printing out a string. So far, we're actually just asking the string to be returned. And that's the reason we see in and out with these cells. And that's also the reason we actually see the quotes in the output below the cell. But we can use the print function to actually print out a string. So we're going to say print hello. And if we run this, note what we actually get back. We no longer see the out in the cell, and instead we no longer see the quotes themselves. We're actually just printing out the actual string. And the reason this is important is because let's imagine I wanted to say hello world 1, and then I also wanted to say hello world 2. If I were to run this, what ends up happening is I only get back that last string. In order to see everything, I actually have to print out the results. So I will say print and wrap this in parentheses, print hello world 1, and then I'll say print and then say hello world 2. And then when I run this, I get to see both strings printed out. So I no longer see that output, I'm actually just printing the results. Now something else I want to mention is that there's actually escape sequences, and escape sequences allow you to kind of have special commands inside of your string. So let's just go ahead and say print hello world, and if I run this, I see hello world printed on one line. But I can actually add an escape sequence, so it's going to be a backslash n, and what this does is it basically tells Python, hey, this n right here, that's no longer the character n. I actually want you to, because of this backslash, treat this as a new line. So if that escape character there, it's going to say print hello, space, then a new line, and then space world. So that's what we see here, hello, space, and world. If I wanted world to be lined up with hello, I could actually just touch it like this, run that, and then I see hello world. And Python knows not to include this letter n there because it's essentially attached to that backslash. So another popular escape sequence is T for tab, and if I run that, I get back hello, tab, so 4 spaces, world. And we'll be talking a lot more about this when we discuss print formatting coming up next. For now, another built-in function that I want to show you is the len function, or the length function. So this allows you to check the length of the string. So I can say hello, and if I run this, I get back length of 5 because there's 5 characters in that string. If there happens to be a space in the string, so I will say I am hungry. Let's make it more obvious. We'll just say I am. And we run this. Here we can see there's 4. So we have I space am, so that counts as a length of 4 characters in the string. All right, We'll stop it here for now, and in the very next lecture, we'll pick up right where we left off, discussing string indexing and string slicing. I'll see you there.
All right. Use what you know about print function to print out the phrase "Hello World." Make sure your capitalization and spacing match. What? Oh. How do I not include a new line in every print? All right.
Welcome back, everybody. In this lecture, we're going to continue right where we left off last time, but we'll be discussing string indexing and slicing. Indexing, where we grab a single character, and slicing.
Uh, print without a new line. Oh, that's how.
And slicing, where we grab a subsection of that string. Let's jump to the Jupyter Notebook and get started. Okay, so to start this all off, I'm going to create a variable called myString, and I'm going to set it equal to the string hello world. So notice there's a space in there between hello world. I run this, and let's check to make sure. Okay, so we have hello world there, ready to go. Now, let's imagine I wanted to grab a single character from this string. In that case, I want to use indexing. So what we do is we call the variable name, we have square brackets off of it, and let's imagine I want to grab the first character, that is capital H, then I pass in a 0, because indexing starts at 0, and that allows me to return that first character, H. Let's try to grab another character. Let's say we want to grab R, so let's count this out. My string, and we want to count from 0, so that's 0, 1, 2, 3, 4, 5. So notice the space counts. 6, 7, 8. So if I pass an 8 there, it should return R. Perfect. So again, this is known as indexing. Now let's imagine we wanted to grab this letter L. Well, there's two ways I could actually do this. I could say my string at 9, because that's right after that R. The other way I could do it is using the reverse indexing we previously mentioned. So starting at 0 from H, I can go backwards in the string, so that D is -1, and that means this L is -2. So if I say my string -2, I will actually get back that L. And then if I keep going backwards in the string, I'll get back that R, which is right before the L. So I will get back this R right there. So you can use both positive index positions and negative index positions to grab elements or characters from the string. And that's really useful again because oftentimes you'll have a variable string, maybe it's someone's name, and you don't know how big that name is, but for whatever reason you want to grab the last letter of their name, then you can always just use -1 and you know that's the last letter of the string. Okay, let's go ahead and continue to discuss slicing. So slicing is a little more complicated because we're grabbing a subsection of the string. So that's more than one character typically. Let's review our string. Oops, my string here is hello world. And I'm going to redefine my string, just so this is a little easier to follow, as A, B, C, D, E, F, G, H, I, J, K. So just kind of a string of the alphabet there. We'll redefine it. And now I have this string of the alphabet. So let's imagine that we wanted to grab a subsection of a string that started at a particular index and then went all the way to the end. Well, the way we could do that is we would say my string, square bracket notation, and then we would say the starting index, let's imagine we want to start at the letter C and then go all the way to the end. So C is at index 2 because it's 0, 1, 2. So what I do is I pass in 2, and if I just do that, it gives me back the letter C. But if I want from C all the way to the end, I can say colon, and that indicates starting at index 2, colon, go all the way to the end, and there we have CD all the way to K. Okay, now let's imagine kind of an opposite situation where I want to grab everything up to a particular index. Then I could say my string, colon, and let's say I wanted to grab A, B, and C. So starting at the very beginning, go ahead and grab all the way up to essentially letter D here. So we'll say 0, 1, 2, 3, pass in 3 there, and then we run this and we get back A, B, C. Now this is sometimes confusing for students because if we check out my string, technically we have the D at index position 3 because it's 0, 1, 2, 3. What you should note here is that the stop index, this term right here for 3, which only returns back A, B, C, that stop index is basically saying go up to, but not including that index position. So go up to the letter D, but don't include it, which essentially says A, B, C. So keep that in mind as you're kind of playing around with slice notation. This stop is up to, but not including. Okay, let's combine these two ideas of a starting index and a stop index by trying to grab a subsection of a string that's in the middle. For example, let's try to grab D, E, F from the middle of the string. The way we can do that is we say my string, open square brackets, and then we start off with our starting index position. In this case, it's at letter D, so that's 0, 1, 2, 3. Then we say colon, and then it's going to go up to the index position of G here, because I just want D, E, F, so we're going to go up to, but not including G. So that's 0, 1, 2, 3, 4, 5, 6. And now if I run this, I get back D, E, F. So let's practice this one more time by trying to grab another subsection of the string. For example, let's try to grab just B and C, these two letters, B, C. So the way we can do that is we'll type out my string, open and close square brackets. Our starting index position is at 0, 1 for B, colon, and then it looks like we want to go up to, but not including D, so that's 0, 1, 2, 3. We'll run this, and there we have BC. And I would encourage you to try to grab a subsection. So choose the subsection of the string and then see if you can grab it. You can go ahead and pause the video and try that out. Okay, to end our discussion, let's quickly discuss step size. Let's imagine that I wanted to grab everything from the beginning of the string all the way to the end. Well, technically, that's just the string itself, but I could also use colon notation for this. I could say colon colon, and that basically says from all the way to the beginning, go all the way to the end. Now, you don't often see this because you might as well just call the string itself, but this is technically valid.
Oh, I am totally not paying attention, and I'm just playing with this assistant um, feature. Why did it log me out? All right.
Valid syntax. The reason you might see something like this is if someone wanted to specify the third parameter, and that is the step size. So right now we're saying go all the way from the beginning to the end in a step size of 1, A, B, C, D, E, F, G. So that's the default step size of 1. However, I can change that by providing a number such as 2, and that says go in jumps of 2. So from A, go to C, to E, to G, to I, to K. So if I run this, I get back A, C, E, G, I, K because I'm jumping in a step size of 2. And we can increase this to be a step size of 3, and then we'll get from A, jump to D, jump to G, jump to J, and then there's no more letters to jump to because we're jumping in a larger step size. So that's how step size works, and you can combine this with a start and stop as well. So we could say something like starting from index 2, go up to but not including index 7 and a step size of 2, and we get back C, E, G. So C, then jump to E, then jump to G. So notice how this all works in combination. You have a start, a stop, and then a step size. Something that you may commonly see is using a clever step size trick to reverse a string. And what you can do is say my string, and then say from all the way to the beginning, all the way to the end, take a step size of -1. And what that does is it actually reverses your string because you're saying from all the way to the beginning to all the way to the end, go and take a backward step, which is then K, J, I, all the way to the end. So this is kind of a little Python trick. Often in interviews, people ask you to reverse a string, and they kind of get annoyed by Pythonistas because they quickly just do this nice kind of slick
Oh.
one-liner instead of doing a for loop, but I just want you to be aware of that. Typically in our code, we won't really be using this too much because it's more of a trick, but again, a very useful one at that. Okay, so that's it for slicing and indexing. Coming up next, we're going to discuss a little bit about some useful string properties. We'll see you there.
Okay. 0, 1, 2, 3, right? Uh, Hooray. Oh no, another one. Tinker. Starting at index number 1 and up to 3, right? Maybe. Oh, 0, 2. No. 1, 0, 0, 1, 2, 3. What? Oh, oh. Not including the less. So it has to be like this. Cool.
Welcome back, everyone. In this lecture, we're going to finish off our discussion about strings by talking about string properties and string methods. Let's jump to a notebook and get started. The first thing we're going to discuss is the immutability of strings. And immutability, it stems from the word mutate, basically means immutate, or you cannot mutate or cannot change. I'm going to show you an example of this. Let's create a variable called name and set it equal to Sam. Now let's imagine we want to change this name to Pam, so change the S for a P. Well, you may think that you would do something like this. Say name, index at 0, and then just set it equal to P. Now for strings, unfortunately, you can't do this. If you try to run this code, you'll get an error because strings are immutable, meaning a string object or str object doesn't support item assignment. So you can't grab one of these characters, one of these elements in the string, and then try to reassign it this way. Strings just don't work that way in Python. Later on, we'll learn about other data types that do support item assignment. All this means is that if we do want to reassign this S to be a P, we basically have to create a new string. And we can do that with concatenation, that is kind of merging two strings together. So I'm going to comment this out, and to create a comment, you just put a hashtag in front of it, and if you run this, you won't get anything out. So basically anything with a hashtag is just commented code that doesn't get run. Let's explore this example of trying to create the string Pam using what we already have about name. So the first thing I want to do is try to grab A and M. So let's use the slice notation that we learned about earlier. We're going to start at index 1 and then go all the way to the end. So let's check that. Okay, so that's AM, perfect. So we'll assign this to something like last letters is equal to name 1 all the way to the end. So then if I take a look at last letters, again I can use tab to autocomplete here. It says AM. And now what I can do is I can concatenate P to last letters. And the way you do that is with the plus sign. So we can say P plus last letters, and then we get Pam. So this is known as string concatenation. Let's explore a couple more examples. I'm going to say X is equal to hello world, and then I could say X plus it is beautiful outside. And then if I run this, I can see hello world, it is beautiful outside. Something to keep in mind is note that there's no space here because there was no space at the end of world and there's no space at the beginning of it. So what would be nice is if you add a little space there, so when you run this again, hello world, it is beautiful outside. Now if I do this multiple times with a reassignment, so I could say X is equal to X plus it is beautiful outside. Now when I run this, I've redefined X, so I can see now, hello world, it is beautiful outside. If I accidentally ran this cell more than one time, I'd add in it is beautiful outside a second time. So if I run this again, notice how my in numbers are going to change right next to the cell. Now it says, hello world, it is beautiful outside, it is beautiful outside. And we could keep doing this, and you keep adding it on. So this is string concatenation, and it allows you to quickly put strings together. There's also multiplication you could do to kind of do multiple string concatenations at once. Let me show you what that looks like. So far we've used a plus sign to kind of concatenate two strings together or merge them together. But if you had the letter equal to Z and you quickly wanted 10 Z's, what you could do is say letter times 10. And there you could see essentially someone sleeping here, Z, 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 10 times. So that's using multiplication with letters, and then that's using a plus sign with letters. Something to keep in mind when you're performing string concatenation or string multiplication is that you're going to get errors if you try to concatenate a number with a string. I want to show you what I mean by that. Imagine we're doing 2 plus 3. If we run this, we get 5. That makes sense. If we do 2, the string 2 plus the string 3, now that they're strings, it's not going to add them together. Instead, it's going to perform concatenation. So here now we get back the string 23. And this is a callback to dynamic typing where we had to be really careful about the data types. So keep this sort of problem in mind that your user may end up putting in strings, and then later on in your code, if you start adding them together, you may end up with an unexpected result like 23 instead of 5. So this is a really prime example of both the good and bad of Python's ability to be very flexible. So it's very flexible, meaning you're not.
Uh, oh, it would be a string and not a number. Never mind.
Getting an error here, but maybe it's a little too flexible because you expected 5 and it gave you back 23. Later on, we're going to learn about a lot more ways that we can kind of prevent these sort of mistakes or errors. Let's continue on by discussing some built-in string methods. So objects in Python usually have built-in methods, and these methods themselves are essentially functions that are inside the object. And later on, we're going to learn how to create our own functions and our own methods. For right now, let's go over just a few useful methods. I'm going to create a new string. Let's call it x and say it's hello world. And if I hit x dot and then hit tab, I should see this list pop out in the Jupyter notebook. And this is a list of all the attributes and methods that are available on this string object. Now again, make sure you've already defined x, otherwise you won't see anything. So make sure you ran that cell that says x hello world, and then in a new cell say x dot, hit tab, and you should see this list. So as you can see, there's tons of methods here, and we're not going to go over all of them right now.
Oh,
We're
okay.
just going to go over the most useful ones that you'll be using later on
What's
in this
this?
course. So to quickly uppercase everything in a string, you can say dot upper, open and close parentheses, and it will uppercase everything in the string. Keep in mind, this method is not in place. That is to say, it doesn't actually affect the original string. If you did want it to affect the original string, you'd have to reassign it. You'd have to do something like x is equal to the upper version case of x. So keep that in mind. I'm not going to run that right now because I want the original x string. And if you accidentally did a reassignment, you can always just say x is equal to hello world again. All right, so we have the upper method. Something that's really common for beginners as a mistake to make is that they accidentally just do upper and they forget those open and close parentheses. And if you run this, it'll just say, hey, this is a function string.upper. And basically what Python is saying is, oh, you haven't actually executed this method or function yet. Instead, you just asked me what it was. So when you call it without open and close parentheses and you get something that looks like this back, it means that you haven't actually executed that method or function to occur. Instead, you just kind of asked Python, hey, what is this? So because there's an upper method, there's also a lower method, which is going to lowercase every letter. Notice here now H and W are lowercased. Then there's also the split method, and the split method allows you to quickly create a list off of a string. So here we can say we have hello and world. Now we haven't really discussed lists yet, so they are coming up. So all I want you to think about right now is that if I use .split, it will split a string based on the white space or based on the letter you pass in. So let me show you what I mean by that. So I will say x is equal to, hi, this is a string. Run that. And then if I say x.split, I get back everything split by the white space. So I get, hi, this is a string, nicely organized in a list. However, I could pass in any sequence of characters that I want to split on. So by default, split will split on the white space, but I could actually split it on any letter I want. So now it's going to split on the i's. So if I run this, we should get an interesting result. And here it's essentially removed all the i's because it's splitting on them. And now the white space is included. So I get h, and because there's an I there, it removes it and then gets everything until the next I, so space th. And then there's an I there, removes it, gets everything until the next I, which is an S space. So notice that's here, and then so on. Again, another I, and a big portion of string, get an I, and then an NG. So that's how you can use split to quickly create a list out of a string. And we're going to be covering lists in a lot more detail later on. Okay, coming up next, we're going to talk until the next I, and then because there's an, and now the white space is included. So I get H, and because there's an I there, it removes it, and then
Ooh. What was my exit again? Hello world. So if I do O, and then it'll skip it, right? Nice. Okay.
Gets everything until the next I, so space th, and then there's an I there, removes it, gets everything until the next I, which is an S space, so notice that's here, and then so on. Again, another I, and a big portion of string, get an I, and then an NG. So that's how you can use split to quickly create a list out of a string, and we're going to be covering lists in a lot more detail later on. Okay, coming up next, what we're going to talk about is string formatting for printing. There's a lot of useful methods you can use to quickly print out other objects along with your strings. So far, we've only learned how to use print as a basic function where we say print hello, but there's a lot more power to the print function that we haven't actually seen yet, as well as the .format method. So let's go ahead and cover that in the next lecture. We'll see you there.
I need a break. I need to make a new BRB scene. Okay, I'm back. And I am gonna go eat because um there is food waiting for me. So I guess be back later if I want to code again tonight. Um yeah. Thanks for watching.